12, Kyle here.
Jason here.
Dixon here.
And Justin here. The speed of light is 1.08 times 10 to the power of 9 kilometers per hour, and is known to some as the universal speed limit, which we can never surpass. Or can we?
Well, to first start off, what is light? Light is electromagnetic radiation that is on a certain section of the electromagnetic spectrum that is visible to our eyes. What is light made out of? They're made out of photons. Photons are elementary particles that cannot be split up, only created or destroyed. Light is also strange in that it acts like a wave, but also as a particle. Light always moves at light speed, no matter what. There is no acceleration for it to go to light speed.
There are many theories on ways to go fast in space. Let's take the wormhole for example. Imagine this is a spaceship. If these 2 points in space are a light year apart, and this spaceship can move at the light speed, it'll still take a year. But if you were to go into a wormhole, come out the other side and live, you would technically move faster than light. Controlling where you end up is another matter. Wormholes are theoretical, and we aren't sure they exist yet. Since we can't control where we end up, we could go either 5 meters or 10 billion light years away. Wormholes are just like portals.
Oh, I didn't see you there. See, no matter what frame of reference, the speed of light is constant and it will always be 299,792,458 meters per second. Light speed is used in Einstein's famous equation, E equals mc squared. Using this formula, as we approach light speeds, our mass increases, as does energy. So, to reach light speed, we need infinite mass and infinite energy. So, the particles that make up light, photons, they can move at the speed of light because, well, they are massless.
Diving into quantum mechanics, there are methods of going faster than the speed of light. When a particle quantum tunnels through an insurmountable barrier, it actually travels faster than the speed of light. This tunneling process can be explained by the Heisenberg uncertainty principle and wave-particle duality of matter. Usually, only a particle can tunnel, but there are chances that a human can also quantum tunnel, even though it is nearly zero.
Or what about tachyons? Tachyons are theoretical particles that already move faster than the speed of light. They have imaginary mass. But what is imaginary mass? Well, take out your calculator and square root a negative number. What do you get out of your calculator? Well, it should say domain error. Scientists have used these imaginary numbers and put it into real formulas used by scientists. And what comes out is a particle that moves faster than the speed of light. Well, we can't magically become a theoretical particle. We could theoretically use these particles and create a tachyonic anti-telephone that can send signals faster than the speed of light. Tachyonic anti-telephone can send signals into one's own past.
Currently, the fastest that humans have ever traveled was during NASA's Apollo 10 mission, which took place on May 18th, 1969. This mission involved a 3-man crew aboard the module Snoopy. They went to the moon to make preparations and making sure all components were in place for the next mission. On their way back, they reached speeds of 39,897 kilometers per hour, making the fastest manned vehicle known to date. Of course, as humans, we want to go faster. One theory brought up by aerospace engineer Roger Scheuer was the electromagnetic drive, or the M drive for short. This drive supposedly needs no fuel and therefore can accelerate without the worry of running out of fuel or having to slow it down. However, because of the lack of fuel, the M drive is also called the impossible drive, as it seemingly breaks Newton's third law of motion, which states that for every action there's an equal and opposite reaction. This drive would propel without pushing against anything. The way it works is that at the end of the engine, there will be an asymmetrical cone, one end being much larger than the other. The narrower end of the cone will produce microwaves within the cavity. These waves are contained and will continually bounce off the walls of the cone, creating electromagnetic resonance. Because the cone is shaped the way it is, the electromagnetic field in the drive becomes directionally dependent, or anisotropic. In this case, it means that there are more waves in the larger end of the cone, causing the electromagnetic field to push the drive away from the direction of the large end of the cavity. The M drive has had a few tests done to it, which produced very little results. It is likely we will not see this in the near future. However, Schroeder wasn't the only one to theorize ways to go fast in space.
Okay, so with EM drive out of the way, I can finally talk about some more interesting theories. Take the nuclear thermal propulsion, for example. This allows the spacecraft to travel faster by providing a more efficient and lightweight system. However, because it is very dangerous, it must be used really far away from the Earth. This nuclear thermal propulsion could potentially be 100 times more effective and more powerful than chemical systems of comparable weight. The way this works is that the propulsion heats a fluid, which is usually hydrogen, in a high temperature nuclear reactor that creates thrust to move the rocket in space. With a system like this, we could easily cut down the time needed to travel to places in our solar system. Okay, so VASMIR, which stands for Variable Specific Impulse Magnetorrocket, is a plasma-based propulsion system which is studied by NASA, or more specifically, Franklin R. Chang Diaz, who was the first Hispanic astronaut to study this. But anyways, VASMIR works by using a large electric power source, such as nuclear power, to then using hydrogen as a rocket propellant. And since hydrogen is plentiful in our solar system, this allows VASMIR-powered spacecraft to be launched with enough propellant to reach its destination. And when it reaches its destination, it can collect more hydrogen for a trip back. A trip to around Mars will only take around 3 months with this system, compared to the conventional chemical rocket, which takes 6 to 9 months. And with less time in space, that would mean less exposure to space radiation for the astronauts. Okay, so this theory is also by NASA, and that is the Alcubierre warp drive. It was first proposed by a physicist named Michael Alcubierre in 1994, and his design called for an American football-shaped spacecraft with a flat ring attached to it. What this does is allow space-time to warp around it, and causing the ship to accelerate 10 times the speed of light, without the ship itself ever breaking the speed of light. For example, a trip to Alpha Centauri, which is about 4 light years away from Earth, would just take around 5 months with this spacecraft. The biggest problem with this idea was that it required a large amount of energy to power it, but up until recently, Dr. Harold Stoney Way, a researcher at NASA, has discovered a way to significantly reduce the energy needed by changing the shape of the ring around the ship from a flat shape to a more donut shape. So instead of requiring a ball of antimatter the size of Jupiter, only around 500 kilograms was needed. However, antimatter is incredibly dangerous, as even 1/3 of a gram of this had energy equivalent to a Hiroshima blast. So with this being said, if this theory does become real, we will really need to be cautious about it.
Gosh darn, second place again. Oh, as Dixon has stated before, we would need an infinite amount of energy to accelerate to the speed of light. Due to relativity, which states that the faster you move, the more mass you have. As you approach light speeds, your mass would become infinite and ultimately slow you down. This is why traveling at light speed using the conventional way is impossible. Currently, the highest achievable speeds by a manned spacecraft is the Apollo 10 and its crew, clocking in at around 39,897 kilometers per hour, which is approximately 32 times the speed of sound. But how fast is that relative to the speed of light? Unsurprisingly, not very fast. You see, although we can travel at 32 times the speed of sound, that is only 0.0037% the speed of light. We haven't even scratched the speeds needed for interstellar travel. The effects of light speed travel include but are not limited to time dilation. Time dilation means that while traveling at light speed, you experience less time than those not traveling at light speed. For example, if you were traveling at light speed and you experienced 30 seconds, those not traveling at light speed or those on Earth would experience probably double the time, maybe around 60 seconds. But that's uncertain. There's an equation for time dilation, which I'll leave over here or here or wherever. But time dilation occurs because the speed of light is the same to all observers in the same media. Therefore, the rate of time experienced by the observer changes in respect to objects moving at light speed. Traveling at light speed would also cause your field of view to narrow into a cone, as the photons would be traveling to you in the forwards direction. Not only that, but even if we could go at light speed, the g-forces that we would experience would be so insane that we would ultimately be crushed into a noodle.
So what's the final answer? How can we improve our interstellar travel? Can we even go faster than the speed of light? Well, to answer the latter,
For all we know, we probably cannot. If we were to move at the speed of light, we need to have infinite energy and infinite mass. If you think about a person with infinite mass, do you think someone that's as big as the universe? It's a fruitful thought. And if we had a spaceship that could go at the speed of light, they would need an unimaginable amount of fuel. But even if we were to go green and not use fuel for our spaceship, even the smallest space debris would absolutely destroy our gnarly spaceship. So, as for right now, at this current point in our timeline, going at the speed of light is probably just a dream.
even if this material could withstand all the debris and whatnot in space, it would also need to be able to withstand all the G's acting upon it while moving at fast speeds. But even if we had such a magical material, we still can't move faster than the speed of light because the protons that make up this material only go at the speed of light. As for interstellar travel, well, they're all just theories for now. The M drive, the Vasimir, the Alcubierre warp drive. All these are unique and have different ways of going through space, but none have been in practice yet. I believe that in the future, we will be able to see these ideas become a reality. However, not the near future, but the way technology is advancing so quickly now, I believe sometime in our lifetime.
And as always, thanks for watching.